It's got extremes of temperature, extremes of vacuum, high radiation fields, all kinds of things that are really inhospitable to human life.
Our eyes and ears are robotic proxies sent on missions to discover the secrets of our solar system and beyond. They are space probes, and they were built to survive the hostile atmospheres and perilous worlds that mankind cannot.
Our space missions are able to survive these difficult environments, and they can go places and do things that we could never dream of without them.
Some probes, like the Hubble Space Telescope, float comfortably in Earth's orbit, while others, like Deep Impact in 2005, are ordered on kamikaze missions to smash satellite probes into comets. Others are sent to uncover the secrets of planets like Mars, Jupiter, Saturn, or their moons, imaging and analyzing them from orbit and landing on their surfaces to explore or dig for samples.
Our probes are used to answer fundamental questions about planetary composition, atmospheric composition, geologic atmospheric processes, how are planets both similar to and different than Earth, and the big picture question, is there life?
The hunt for life on other worlds began over 2,000 years ago when Greek astronomers began gazing at planets. In the 21st century, humanity is finally poised to find it.
Sending out probes into the solar system and even beyond is part of a long-standing mission we've had to understand not just ourselves here on Earth, but the rest of the solar system. And in some ways, that quest helps us learn more about ourselves in terms of where we may have come from and whether there are any other examples of the environment we see here on Earth.
The latest quest begins with an ultra-high-resolution digital infrared roadmap. On December 14, 2009, a Delta II rocket delivered a small package into orbit 300 miles above the Earth. It's called WISE, and it's creating the most detailed infrared photograph of the universe to date.
WISE is the Wide Field Infrared Survey Explorer, and it's a small-sized telescope about 40 centimeters in diameter, so that would sort of fit under my arm here, and it's surveying the entire sky at 4 infrared wavelengths. Everything from the Earth's closest neighbors, the asteroids and comets, to the most distant parts of the universe.
Unlike the Hubble telescope that generally images wavelengths of visible to ultraviolet light, WISE probes the universe using infrared light.
Human beings perceive infrared as heat. When we feel the sun's warmth on our skin, what we're really sensing are the infrared rays coming from the sun. I'm pouring out infrared light as I sit here, and we can use infrared to look for things that are sort of similar temperature, like, for example, asteroids. We can also use infrared to look for the most distant galaxies in the entire universe.
Many of these distant galaxies can't be perceived in the visible light spectrum. The WISE infrared telescope becomes like a magic set of glasses.
So just like a firefighter uses infrared goggles to look through smoke in a burning building to find people, astronomers can use infrared to see through dust clouds to look for forming stars in their cores.
But revealing these hidden heat signatures first requires an extreme deep freeze. WISE's 4 million pixel telescope can only photograph infrared images if the telescope is colder than the objects it searches for.
So we need to make sure that we're not blinded by the heat of our own telescope. On WISE, we use a tank of solid hydrogen that's frozen near absolute zero, and this keeps our telescope and our instrument cold. Just like a cooler full of ice, the frozen hydrogen on board WISE is eventually going to sublimate away. When we run out of all of the hydrogen ice, the telescope and the instrument will warm up to the point that we'll no longer be able to see.
Frozen to minus 447 degrees Fahrenheit, the hydrogen can only last for about 10 months. By that time, some 1.5 million photographs will create a giant composite picture of the heavens. A cosmic road atlas that can reveal new worlds for future space probes to target, potentially worlds with alien life forms. But if we are to find alien life many light years from Earth, we'll need a critical clue to lead us there. On Earth, that clue covers 71% of our planet: water.
One of the main reasons we're interested in finding liquid water is that we really would like to know, is there life elsewhere in the solar system? Life on Earth, as we know it, needs water to survive. It needs water to form. We hope to find life elsewhere, and a signpost for life might be first finding a place where there's water, liquid water.
Throughout human history, there was no proof that liquid water existed anywhere else in the universe besides Earth. Until a sophisticated space probe arrived on a mission of discovery to the planet Saturn in 1997. Cassini traveled 400 million miles and took 4 years to begin a multi-year spy mission to uncover the secrets of Saturn.